Let's solve a minimal spanning tree problem. In this problem, in this problem, we have to set security video cameras. So for security video cameras, we have 1, 2, 3, 4, 5, 6 locations, and to set the video cameras, we have to take the cables to those positions. And the cables are the cable and the pipeline for that cable is pretty expensive, so we have to try to minimize the cost or minimize the distance as much as possible. To do that one, we will run minimal spanning tree. The method we follow is called Prim's algorithm. So let's see how can I do it. I will just use this picture given in here, and I will show you on that picture. You can draw it separately and do it during exam. So to conduct minimal spanning tree, we have to start from a specific location as we have. So as we have numbers in here, 1, 2, 3, 4, 5, 6, we will start with number 1. And the method of conducting minimal spanning tree is to start with a point and choose the shortest path or minimum path from that point to the next point. And when we cover this point and when we reach another point, the second point, we have to find the shortest distance from these 2 points. So this is how we can cover the whole, we can touch all the points using minimum distance. That's why this is called minimal spanning tree. Now, so first we will start with number 1 and say here is our number 1. And from number 1, you see we have 3 connections from number 1. From number 1 to number 2, number 1 to number 3, and number 1 to number 4. We will choose the minimum distance. So from number 1 to minimum distance is number 2. So first let's draw it. Number 1 to number 2, which is 50. Now we have to choose the minimum distance from number 1 and number 2. So you see from number 1 we have 2 left, which is number 1 to 3, 65, and 1 to 4, 75. And from number 2 we have 2 to 6, 2 to 3. So 2 to 3 is the lowest, it gives 37. So now we will choose 2 to 3, 37. Now from number 1, number 2, and number 3, we will choose next point, next minimum distance. So from number 1 we have, from number 2 we have 2 to 6, 53. From number 3 we have 2 to 6, 2 to 5, and 2 to 4. And you see here 2 to 4 is the lowest distance among all the other distances. So we will choose 3 to 4, which is 26. Now we have 2 more left. So we have 6 and 5 left. Now 6 and 5 are connected with number 2, 3, 4, all of them. So you see from first, if we see from 2, it's 53. From 3, there's 48. From 3 to 5 is 41. And from 4 to 5 is 56. So minimum among them is 41, 3 to 5. So we will choose 3 to 5, which is 41, number 5. And now only 6 left, and to 6, from 5 to 6 distance is the lowest. This is it. So this is our minimal spanning tree. We will draw it 1 to 2, 2 to 3, 3 to 4, and 3 to 5, and 5 to 6. That's it.